Okay, so now that we kind of know how to use the table and the different kind of scenarios we might get, let's try some actual problems with this. So let's say we have a final exam in a stats class that's normally distributed with a mean of 63, standard deviation of 5. Find the probability that a randomly selected student scored more than 65. So I'm going to draw this. You can find the z-score first if you'd like, but I'm going to draw this picture first. So I have a mean of 63 and they got 65 on the exam. So it's relatively close to the 63. And then they want to know the probability that they scored more than 65. So that would mean we're shading to the right. So here's what we're going to do. We need to find the z-score for this because I can't use the table unless I'm talking about the z-score. So the z-score is going to be 65 minus 63 all over standard deviation of 5. So that's going to give me 2/5, which is 0.4. So that's my z-score I'm going to look up off the table. Now, because I'm wanting to go to the right, I'm going to subtract this from 1. So the answer I get when I look it up off the table for 0.4, I'm going to subtract it from 1. And from the table, I'm getting 0.65542. So subtracting that from 1, 65542, I am getting 0.34458, or I could just say about a 34% chance. I'll just round it for answering the question. And of course, that kind of depends on how they want you to round on the homework. Awesome. All right. So kind of get the idea, draw the picture, find the z-score, use the table, answer the question. So for the next one, we're looking at they scored less than 85. Okay, wow. So 85 is quite a bit away from the mean. So if that's 63, 85 is going to be like way over here. I'm going to guess quite a bit of ways. And they want to know less than 85. There should probably be a really good chance that's going to happen. Okay, so let's find the z-score. Let's see how far away it is from the mean. So 85 minus 63 divided by 5. And that's going to give me, I'm actually going to go ahead and do the whole thing. So plugging it in all the way, I'm getting 4.4. Wow, 4 standard deviations away from the mean. I probably should have put it even further. Okay, now when we go to the table, 4.4 is 0.99997. In fact, pretty much by that point, they're all kind of looking the same in the probabilities. And I guess if you really wanted to round it, I mean, it's kind of like 100% chance that it's going to happen. I think that's completely reasonable to say. Really, that means that nobody's getting that high of a score, like, or that everybody's going to be under that score. Okay, so the next question wants us to find the 90th percentile. So percentile is representing a number that every number is less than or equal to that number. So when we're saying the 90th percentile, that means that we're trying to find the area under the curve where to the left of that number, whatever it is, that this is 90%. So we're kind of working backwards. We're being given the percent and we need to find the X value. Okay, so there is a formula. Oops, I'm so sorry. There is a formula for this. Wow, that went way up to the top. I'm so sorry. where we will find x equals z plus sigma times, oh, I'm sorry. I said that backwards. So it's mu plus sigma times z, or z times sigma. I can't remember which order we put it in. So this allows us to find the data value when we know what the z-score is. So we know what the mean is and we know what the standard deviation is. What I want to do is I want to find what z-score gives me 90%. So I have to kind of work backwards. I have to find the z-score on the table that has a 90% for its percentage. So we're going to have to approximate. We're going to have to get as close to 90% as we possibly can. And when I look at the table, let's see. I see in the closest I'm seeing to 90%, I'm going to go ahead and write this in green, is 0.89973. I also see a 0.90147, but I think that's a little bit high. Okay, so the z-score that this one is working for, that number 0.89973, the closest I could find, is 1.28. That's the z-score. So that's what I'm going to use to find the data value. So 63 is the mean. The standard deviation is 5, and I'm going to multiply it by 1.28. And that gave me, I'm going to add 63, so I'm actually just going to work it all the way out. So 69.4. So anything less than 69.4 should be, or the 90th percentile. So every score is going to be 69.4 or less. That kind of makes sense based on the fact that when I looked at 85, it was like 100%. So 85 was way too big of an overshoot. Okay, so that would be the 90th percentile, 69.4. Let's try that again. I know that's a little bit more difficult working backwards because it's not as precise. So this one, we're looking for the 70th percentile, which means we're finding a smaller area, but still 70%, so the majority. So we want to find the closest we can to 70% on the table. And I like to write it down because it just kind of helps me keep track of everything. So 70%, let's see, I see a 0.70194. And I see a 0.69847. 69847. So I'm going to see which one's closer. So that one is closer. 0.69847 is closer. All right, so I'm going to write that down. 69847. And that is with the z-score 0.52. All right. So using that z-score then, I'm going to use this formula. I'm going to take the mean, standard deviation, I'm going to times it by the z-score. I am getting 65.6. And 65.6 then represents the number that is that all scores are 70% or they're equal to that score or below. Now I just want to bounce to the z-score table really quick just to kind of show you these numbers I'm looking at. So that last one I was looking for 70%. So I was kind of trying to figure out which of these two values was closer to 70%. Because I saw the 0.70 and I'm like, oop, okay, that's like where I want to go. So I kind of wanted to make sure. And I subtracted them just to see which one was actually closer. And it turned out that this one was closer to 70% than the other one. All right. So I'm kind of looking in the middle and I'm doing my best to find the closest value I possibly can. And then I'm using that Z score associated to the values. So I'm picking those numbers out. And that's what I'm using when I'm plugging it into the formula.